Hello and welcome to video 15 for Math 123. This is actually going to be the last of the videos for the material that you guys are going to be responsible for. Hopefully the last of the material you're going to see on the Praxis exam. Video 16, which we'll do after this, will be test taking tips and techniques. So with the Praxis standardized tests, there's certain things you can do to improve your chances and improve your scores. And that'll be the last video we do. But in this video, this is the last for our geometry section. And we'll be talking about circles and then perimeter, area, and volume. So let's get into that. First of all, circle. A few things about this, a few features. So when we have the circle, we have what's called the center point, and that by definition is right in the center. The line that cuts all the way across the circle is known as the diameter. And again, this is my center. And any line segment that goes from the center out to the edge is called a radius. And so the diameter is what? The diameter is actually two radius, one to one side, one to the next. So the diameter, we want to call that d, is equal to 2 times the radius. So depending what we're given in the problem, if we're given the diameter or if we're given the radius, and if we're using a formula that uses radius, so for example when we talk about the area is pi r squared. So we need r, the radius, but if we're given the diameter, we would have to divide the diameter by 2. So that's the relationship between them. A circle contains 360 degrees. The circumference which is, if we start at one point and go all the way around. So circumference is essentially the perimeter of a circle. We don't call it the perimeter, we call it circumference. In this formula, C is equal to 2 times this value pi times r. And again, what? Diameter is 2 times r, so this could also be written as diameter times pi. And pi is a representation of a number, I should put approximately 3.1416 if we go to 4 decimal places. So if we're asked to find the circumference, if the radius is 3, it would be 2 times 3 times 3.1416. As I alluded to a minute ago, we have the area. So if this was a pizza and we wanted to know, okay, what's the circumference around, we would use this formula here. If we wanted to know the area, so how much pizza, that has the formula pi times the radius, and we square the value of the radius. So if the radius was 3, we would square that and get 9 and times that by the value pi. So that's pretty much what you're going to need to know for the circle. What's diameter? What's the radius? How are they related? What's circumference? What formulas can we use for that? And what's the radius? What formula would we use for that? So the last bit with geometry then is going to be perimeter, area, and volume. So first, perimeter. Quite simply, it's the distance around the outside. So again, for a circle, that's circumference. That's the distance around. If it's a triangle, how long is each side, the distance around the figure. If it's a square, how long do we move around each figure. Again, it's the distance around the outside. So if on the praxis, if you're given, let's say, a triangle and a semicircle, and they want to know what's the perimeter of this figure, it's only going to be the outside pieces. So that part there, we don't count the line in the middle, so we wouldn't figure out, okay, what's the length of that and add it to the perimeter. Think of it like a fence. So this is the shape of a fence. Pretend that line's not in the middle. If this is the figure we have, almost like an upside down ice cream cone, how much fence do we need to go around this whole area? That's what perimeter is. Area, so that's it for perimeter, just the distance around. So depending on if we have a triangle, how do we figure out the sides? We had Pythagorean theorem. We could figure out those lengths. If we have a square or a rectangle, figure out those lengths and just add up all the sides. Area has different formulas for different polygons. So first, if we have a rectangle, the area for a rectangle is length times width, so L times W. A square, well, a square is what? A square is a rectangle, but it has all the same sides. So in this case, if every side is equal to S, well then it's what? It's just S times S, which is S squared. So take one of the sides and square that value. So if this is a square and each side has length 5, well, 5 squared is 25. That would give you the area of the square. And again, if you do length times width, 5 times 5, still 25. Parallelogram, so remember what this looks like. So a parallelogram is a figure that has two parallel sides. We have the height here. And let's say that this side down here, the bottom, the base, we'll call that B. Well, if I take, let's pretend this was a piece of paper in the shape of a parallelogram. If I took a scissors and cut off this triangle here in the left, and then slid it on the table over to here, what's going to happen? It's going to fit right in here. Right, so I had the black parallelogram to start. I took a scissors and cut this piece off and slid it over. Because these two sides are parallel, they're going to match up exactly. So then the new figure that I get, if I draw that in red, is what? It's this, all the way down to here, all the way up to here, all the way across. So it ends up creating what? A rectangle. And the area of a rectangle is what? Length times width. So in this case, whatever this piece was here, I just put it over here. So this whole side is still B and H. So the area of a parallelogram is base times the height. All right, those are the first three. Number 4 is a triangle. And again, instead of trying to memorize all these formulas, if you can remember what the polygon looks like, you can do little tricks like that. Like, oh man, I can't remember what was the formula for parallelogram. Well, let me draw one. Oh, that's right. If I just cut off this corner, slide it around, now I have a rectangle. It's just length times width, which my dimensions are base times height. Triangle, we can do similar, sort of playing around with the picture. So if I have a right triangle, actually it doesn't have to be right triangle, but if I have a triangle here, and this is my base, and this is my height, well, if I was to draw this dotted line, what did I just draw here? I drew a rectangle. And what's the area of a rectangle? Length times width, which in this case the sides I called them are base times height. So the area of the entire piece with the dotted area is base times height. But I didn't start with the dotted part. What? I only started with this guy. And the triangle with the solid lines is what? It's half of this entire rectangle. So the area of a triangle has the formula 1/2 base times height. And again, if you don't remember, if your brain freeze on the test, just draw this like, okay, I have this triangle. Well, if I draw in a rectangle, okay, rectangle's length times width, but I actually only have half of that figure, so I have to multiply the whole answer by 1/2. And then 5 is our trapezoid. And let's look at one of these pictures. So, trapezoid is what? Trapezoid has two sides that are parallel. The other sides not necessarily. So let's call this the top B1 for base 1. Call the bottom B2. And we'll call the height of this thing. So let's assume that it's a right angle. The height is H. Again, we've been drawing all these rectangles. Let's do the same thing here. So instead, I'm going to draw this entire figure again, but I'm going to basically rotate it 180 degrees. So I have what? I have this guy. That looks like that. So it's this trapezoid sort of just rotated around, so the point for this part is now up here. Well, if that's the case, if I match up these pieces, then this is what? This is B2, the dotted blue part. The length of this one is B1, and I still have the height. So now, if I calculate, okay, the area of this big rectangle is what? Length times width, which is B1 plus B2. So that's my length. The width is H. So this entire piece is B1 plus B2 times the height. But what did I do? I created two pieces just like I did above. So I actually, whatever this value is, it's only half of that total value would give me the area of the trapezoid. So that is your formulas. Those are your formulas that you're going to need to know for area. Rectangle. And basically off a rectangle you can figure out everything else. Square, parallelogram, triangle, trapezoid. Just draw the rectangle in if you have to. Okay, now here's my length and width, but I only need half, or I need the whole piece, etc. You don't have to necessarily try and spend your entire time studying just memorizing formulas. If you just remember those little tricks, like, all right, if I draw this picture again, or if I turn this into a rectangle, what do I get? Then we have surface area. So for rectangle solids, so this might be like a cube, or it doesn't even have to be a cube. It could be like a long gift box or something like that, like that they send flowers in or something. So you have these. Well, what's the area of this? Just add up all these pieces. 1, 2, 3. Don't forget you have another one down on this end. 4. Don't forget you have another one over here. 5. Don't forget you have one on the bottom. 6. So just calculate the areas of all the different rectangles. So rectangular 1, 2, 3, 4, 5, 6, and add them up. So calculate each. And add them. And that will give you the surface area. How much, think about if we're like building a box. If I was building that flower box, how much cardboard do I need? Well, I would need enough for all 6 sides, and you could add up, calculate each side and add up the total together. We have a cylinder. So think like frozen orange juice can or something like that, or even like a glass. Well, if I took, and again, the piece around the outside, if I took a scissors, so let's say this was, well, think of like a paper towel roll. So that's the cylinder part, right? But let's assume it had a cap on each. Well, we would have what? We'd have the top cap, we'd have the bottom cap, and if I took the caps off and then took a scissors and cut it in the middle and rolled this out, I would get what? I would get a rectangle. So I'd have the surface area of a circle times 2 plus the surface area of the centerpiece, length times width. So the formula, when you go through all that, is 2 pi r times r plus h. So it's basically what? So 2 pi r, well that's pi r squared, which is our area of a circle, but we have 2 of them, so that's 2 pi r squared. And then the r piece, well 2 pi rh, well that's what? That's what this guy ends up being, length times width for that rectangle. So 2r is the diameter, which is what the distance across would be. So when we roll that out, we get the diameter times pi, that's our circumference. That would be this top part of the rectangle, and then the height is h. So to simplify it, it's just 2 pi r times r plus h. Don't worry too much about this. You're not going to have a lot of questions like this, if maybe any, on the Praxis, but it's good to know. Work a couple of these just in case you encounter it. And then a sphere, so think like a tennis ball. And the formula for this is 4 pi r squared. And I'm not going to go into the derivation of this, but just know that if you have to find the surface area of a sphere, so how much material is needed to make a tennis ball, that would be your formula there. And then lastly, so we had perimeter, just add up all the sides. Area, we had those calculations. Surface area is just if we have a figure, a solid, and we want to know how much material covers the outside. Last is volume. So how much does something hold? So for a rectangular solid, so again, that's like our flower delivery box. The formula for this, so our volume is just length times width times height. So if we have that box, do length times width times the height, that gives us what the volume is. If it was if we were trying to fill it up with some liquid, how much liquid could we pour in there? And the other one is a sphere. And for this one, our volume is 4/3 pi r cubed. So be careful with that. It's not pi r squared, like with the radius and such. It's pi r cubed. 4/3 pi r cubed. And again, those are really the only formulas you're going to need to know for volume. So that's it. We made it to the end here with the material you guys are going to be responsible for. As I said, the final video in this series here is going to be test-taking tips and techniques. Just as important, really, as all these other videos that we've been doing. So come on back. We'll discuss that, but for now, congratulations. You've made it to the end of the material that you're going to need to know for this class and for the Praxis.